Hello students, good morning. Uh, we have seen in our last videos about the different lectures on drilling engineering and also the uh, oil and gas well drilling, then simulation, and also we have seen lastly about the cementing calculations, 7 steps. Now in today's lecture, we are going to see something different on which we are not done in our channel. That is fishing operations in oil and gas well drilling. So let's go to the presentation now. So today's presentation, we are going to see about the fishing operations. Fishing operations in oil and gas well engineering. So what is the objective on this model of fishing operations in oil and gas? So on the completion of this model, you will be able to see perform the how you can do the fishing operation economic, and you can make a decision free manner, and also what are the parameters that will impact the fishing tool selection, and one more thing is the bottom hole assembly, how you design and in the basic fishing operations. And we know the different operations, different types of fishing operations tools, and describe the general procedures for fishing operations. So what is the definition? So fishing is the technique of removing out lost or stuck objects, junks, which are left out during the drilling operation in the cast hole that has been happened. For example, workover operations, or you can say that intentional, unintentional twist of the string during the drilling, parted string during drilling, and falling of objectives during the from the surface, then parted or backed off string following the following a stuck pipe operation, and then parted wireline cables and loss of cones from the beads, etc. So these are the points which you should know. The next is, so what are the main causes of fishing operations? So you can see that deficient or faulty equipments, or human error or negligence, the program is not allowed, or wellbore instability. Therefore, it is important to minimize the risk of fishing by some preventive actions and some equipments. So what are the prevention? What are the preventive actions we are going to take against the equipment? So prevention is the first step to avoid the fishing jobs that is going to happen in oil and gas well drilling. So whatever your tools you are going down in the hole, that we can make a certificate of their final inspection. Then, so next one is the how you make the decision. So the decision is to fish, or you should remove the fish, or the junk should be taken following an economic and fishing decision tree. So you should be noted that the decision is to set a cement plug. So you have to make the cement plug followed by a side track, which can be done instead of fishing operation. That is cement plug. Then next is number 6. So you can see here the all the operations. You can see here the general informations, formulas which you are putting, general information. So you can see here the operations. So general information, the test depth of a hole, and depth of top fishing, what are the daily operations, spread rate, then value of stuck fish. And also uh, these are the input parameters to calculate the optimum fishing time. So which are shown here. The depths are independent of the calculation and is useful to have the recorded to validate the times ensured, particularly if the results to be printed. Then cost ratio formula requires the fishing cost per hour. So you can see here the input to the left are entered on a daily basis, which is giving the cost per day to the fishing operation, and the subtotal is divided by 24 to give the hourly fishing cost used in the cost ratio formula. And then the blank spaces are provided so that if you like to add additional fixed costs, just you can add to the corresponding cost per day. So we can add it. So total per hour equal to subtotal, but spreads what is the spread rate plus 24. So this is your example of cost of fishing, and the cost of side tracking also shown here. You can see here cost of side tracking, and the cost of side track is composed of two things, that is associated with fixed cost and the time from the decision to side track until the original depth is reached. And these are the some common fixed costs associated with side tracking. So in this case, where side track through the casing is required, additional cost may be added in the spaces provided. If the failure rate of the cement plugs is unknown, then the cost should be adjusted. For example, if there is a three plugs may be required, adjust the corresponding cost to three of their values. So you can see the values time to side track. So you can see the time to the side track circulate, top of fish in hours is shown, pull out of hole, then pick up the stinger, then run in hole, circulate, cement plug 1 hour, then pull up cast, so etc. etc. Then pick up the whipstock, milling assembly, run in hole, wait on cement, then set the whipstock or mill casing, pull out of hole, pick up the kickoff assembly and run in hole, initiate kickoff, drill back to the original total depth. So this is the time to side track hours, then total cost fixed. So you can see here the example. So this is your cost of fishing, general information. So one which is in the blue are formulas, which is to be changed automatically with your inputs. So in the your value should be entered in the gray boxes. So next one, next slide. So this is your optimum fishing time calculator, OFT. Minimum OFT in days and maximum OFT. So optimum fishing time equal to 0.4003 into cost ratio to the power of minus 0.7847. So this is the optimum fishing time calculator, and you can see the curve shows the optimum fishing time. The red and yellow bars displays the red and yellow bar displays the range for the minimum and maximum OFT depend on the confidence level entered. So this is the probability time in days. So this is your optimum fishing time calculator. Then next slide. So this is your decision tree example. So you can see here the recovery, problem of success, fishing cost, fishing success, failure, stuck pipe, accumulation cost. Then side track equal to cost of fish plus side track plug and time. Then conclusion, continue the fishing. So this is the decision tree example. You can see here clearly recovery, probability of success 3 days, 50% like that. Fishing equal to success plus failure, which is equal to 266 point K. So this is the decision tree examples, and conclusion, continue the fishing. Next slide. Decision tree example again, recovery probability success 5 days, fishing success, then stuck pipe accumulation cost, then side track equal to cost of fish plus side track plug and time. So conclusion in side track. So this is your decision tree example again for 5 days. Then So typical fishing string. So you can see here the fishing string, typical fishing string. In general, the fishing string should include at least the following components. So work string, accelerator. So you can see here the clearly accelerator, fishing jar, bumper sub, safety jar and fishing tool. So this is your typical fishing string. Then, then preparing the fishing operation. So what is the preparation for the fish? So analyzing the fish, that is the remaining part or bottom part. Then other alternatives than fishing, then type, dimension, outer diameter, inner diameter, length, fishing neck and condition of the fish and causes of the fishing. Stuck pike mechanism, the fish is free or stuck, where is the top of the fish, TOF, what are the local rules and regulations, wellbore condition, open or case door, then well trajectory, tight spots, washouts, or internal or external catching, possibility to run tools through the stuck string, fishing experience of the personnel, prepare on HARC, ensure solvents on the site, and keep the parameters within the limit tools. Then sketches are very important, means the success or failure of a job, then NOR corrected by a wireline measurement. So the two people should keep the figures and compare it periodically. So this is your preparing the fishing operations. Then fishing string general recommendation. The fishing tool should have a higher the tension and torsional limit than the DP drill pipe. It is recommended to use high strength drill pipe that is recently inspected, and then every fishing tools run in the hole should have been previously inspected. The length of DC drill collar should define in order to optimize the impact of the fishing job. So this is the fishing string general recommendations. Then we can see the full recommendations. So fishing operation recommendation number one: ensure that fishing have been inspected pre-well to RAH. Underst- and you have to understand the limit of your fishing assembly, tension, torsion limits, measure and drift the fishing string. Run fishing assembly at moderate speed could cause lost circulation, might hit a tight place and become stuck again. When POH don't create a swabbing action, then avoid rotation while pulling out. So when washing over or washing down, be sure you are getting enough cuttings from out to the offset the amount you are washing. If you are not, then it's possible to build a bridge above the tools and become stuck. So these are recommendations. Then fishing operation again recommendations. Prior to connecting to fish, we have to ensure the following unknowns. The following are should be known. String weight up, down and rotating with and without circulation, free rotation torque of the fishing string, strokes of fishing tools, jarring calculations, safe working loads, strength of fishing tools, and establish the circulating rates and pressures and circulate the conditions mud prior to fishing if required, and ensure that during the fishing operation tool joints are not opposite to the BOPs and circulate slowly when searching for the fish. An increase in pressure confirm tool location on the top of the fish. So at this point you might want to shut off the pumps. So when a fish is free, circulate bottoms up before flow checking and pulling out. So when pulling out, circulate while working fish throughout the spots. Do not rotate the fish. Then also circulate bottoms up if you have been out of the hole for extended period. If the gas is accumulated in the borehole and is not possible to circulate when latched into fish, so the gas may become problem when pulling out. Then next one, type of fishing. So we have open hole or cast hole, then external catching, overshoot, die collar, internal catches, the releasing spare, tablet tab, screw insert, fishing junk, reverse circulating junk basket, junk sub, junk mills, pilot mills, then fishing wireline cables and parted line, then line intact. So these are the your fish types of fishing. Then back off. First one, unscrew the pipe at the selected thread joint above the stuck point using an explosive runout on uh, wireline inside the pipe. Needed if the fishing plan requires screwing a tool into the fish, then drill pipe, collars, and others drilling tools generally have large coarse threads. Back of tubing is difficult because threads are too fine. Then string shot is used to loosen the threads, and sometimes it is sufficient to knock the pipe trees. So this is the back of. Then chemical cutter. So you can see here the chemical cutter uses a propellant and chemical such as halogen fluoride. It's more economical than back off because it is faster, safe for rig personnel since no torque of the pipe is necessary. No flare or burn of swelling of the cut pipe requires 100 feet of the clean fluid above tool when fish out is made. So this is the chemical cutter effect. So you can see here chemical cutter effect. Then jet cutter. So end pipe will be flared good when the well is to be abandoned or when the cause does not allow use of chemical cutter. May cause damage to casing or an adjacent string if the pipe touching it when out cut is made. So you can see the jet tubing cutter. So next is mechanical cutter. So you can see the cut the pipe internally or externally using a tool equipped with set of knives. So not used very often since it is more economical to use wirline tools. Should be used if other options are definitely not available. So you can see here is mechanical cutter. Then operational procedure. Anchor by slowly rotating the right while lowering the string. The wiper blocks resist rotation. This in turn will move the slips into engage the position while rotating at 10 to 20 rpm and watch the torque. Free location, free rotation with little or no reverse torque indicates that the cut is complete. Then fishing, that is washover. So washover strings are required where the formation is you can see the bridged off and stuck the string. The string has become cemented. Washing, milling over stuck completion or drilling the BHA usually made with heavy wall, N8 grading, casing, flush pipe, OD must allow rotation in the whole or casing. Annual carriers must be sufficient for the circulation and prevent over torque. So a safety joint is used with a washover string. Do not run over more than 30 mm to 50 mm of washover string at once. So this is the washover burn shoe. You can see used for wash slightly milling. You can see out facing can be both side or outside. And this is your impression block. Provides impression on the top of the fish and obstruction. Low cost alternative to downhole camera. Side mounted circulation ports allowing full circulation. So this is your fishing junks. Tools or equipment accidentally left in hole, broken off in the hole or accidentally dropped. Use impression blocks if it is unknown what the fish is or how it is positioned in the hole. So this is your fishing junks. Magnets. So permanent magnets have circulating ports around their outer edge. You can see that cannot be flown by helicopter, cannot be turned off when running in hole. Then electromagnets. So run on electrical conductor lines, cannot reach the fish if it is covered with debris. So magnets only pick up the ferrous metal and cannot recover brass, aluminum, carbide and stainless steel tools. So this is your magnets. Then reverse circulating basket, you can see the at the bottom of the bodies inside is finger basket. So you can see here allows debris to pass one way very clearly. Normal circulation can be used. Then junk basket. So this the collects loose junk in the basket. So it can run directly above bit or junk mill. So it's a junk basket. Then so this is the junk mill used for milling a junk or shortening tubular. It is usually dressed with tungsten carbides. Then taper mill or pilot mills used for opening up a restriction steel and as a guide mill. Then this is fishing external catches. Then overshoot 150 series used more than any other fishing tool. So this is the overshoot 150 series. The A packer seals of the outside the fish allows the circulation down through the fish. So right hand rotation expands the grapple by maintaining the right hand rotation. Overshoot may not withdrawn from the fishing. And this is your overshoot 150 series. Then overshoot 70 series. You can see here the schematic continuation of overshoot. Then this short catch overshoot releases in the same way as the 150 series overshoot by firstly sharply bumping downward and then turning the right hand rotation. So this is what you do in those cases. So you can see here. And decaller, it is used for fishing the outside of the tubular, used when the cut outer diameter of the fish is not known. When the decaller engages, it's recommended to run a safety joint in order to disconnect drill string. This is your safety joints. It is used in drilling, fishing, and washover strings wherever a releasing safety connection is needed. It should be installed in the assembly only when using taper tabs, decaller or washover strings. So this is your to disengage and to engage. So you can see here, and this is your fishing internal catches. This is your spares used for catching the internal diameter of a tubular fish. There are several types: shoulder type, flush type mandrels. This is spare operation. To engage, lowering the fishing string slowly until the spear has entered the fish to despite depth. And to release the bump down, full weight of the fishing should be rotated and the string should right and elevate the string until it is clear of the fish. This is the internal fishing tapper tap. You can see here it is used as a last resort. Run with safety joint to able to disconnect the fishing string. So this is your schematic what happens. So wireline fishing line is intact. Cable guide method, cut and strip, very high success ratio. Cutting cable and strip over is the time consuming. Logging operation can be resumed. Then side door oversheet, you can see here side door method, special overshoot with gate, risk of pinching the lines. Deep open holes, line become key seated or differently struck. So wireline fishing line is parted. So you can see rope spears and grabs, box tabs, fishing jar objectives, then bumper subs, record in all fishing assemblies, then fishing jar. This is your accelerator known as slinger, enhancer, intensifier, accelerator. And this is the effect of accelerator and washover operation, starting rotating with low RPM. Once backup is achieved, the washover operation is repeated. And operation sequence. Instable cable hanger, cut the line, install spirit overshoot, install spirit. And operation sequence 2. So this is jarring recommendation. So these are the points which you should remember. So thank you. Today we have seen the fishing operations in oil and gas well drilling. Thank you. Subscribe my channel. We will see more on fishing in our next lecture. Thank you. Subscribe my channel.